Okay. Now suppose that we want to use Matlab. We want to use Simulink as a part of the Matlab for integration of one differential equations. Say we have equation of this form here. Okay. We'll start shortly. Here. Suppose that we have the acceleration of in somewhere. A equal, for example, it's equal to constant, say 5 e to the power minus t. We want to find distance, yes, and velocity in terms of time. We need to integrate this. To integrate this, you know that we find the initial plus integration of 5e minus t times dt from 0 to t. We end up here with v equal to vi plus integration of this number will end. Okay, now we'll have. Okay, it will become t minus t from 0 to t. We invert it because of negative here. We integrate, then we divide by -1. So we solve the problem this way. So I have here v initial plus 1 minus 5e minus. It should be the this should be the speed at a given time. So when t is equal to 0, this v is equal to vi. Now, now to find s, we need to integrate further this term on t from 0 to t plus integration 1 minus 5 e minus t. Okay, from 0 to t. Now, so we have here vi. Integration of the second part will end up with t. Okay, we have minus 5e minus t, so this becomes plus 5e minus t. Okay, this from what? From 0. All right. Now, we will have solution at the end, looks like vi plus 1, because we have t coming here, plus 5 e to the power 0, so it is 5 here, 5e minus minus what will happen here? So here to integration becomes integration of this one we divide by okay, 5 e minus t minus like that. Okay, so we can rearrange them. It will become something of this form. Minus 5. Not 5. Okay, so this is the distance. Now we want to uh, integrate this equation. The equation here is A. So A here means T squared is over B T squared. How to do this? Now, under Simulink, we have something called integrator. We have a first integrator. So we think about acceleration, then we end up with velocity. If you integrate, you end up with S. The equation itself as a flow, equation will start from here, and we want to go back to our acceleration is 5e minus t. So here, acceleration itself is, so we can write it like that, v squared s over t squared equal to 5e minus t. Okay, so we need to integrate this. We obtain ds over dt. Integrate it further, we end up with this. Now, this loop should be, okay, here we ask, we use scope to see what happened for the velocity. Here, if you put another scope, we can find what happened to distance. Okay? So here we can see V, diagram of V, here diagram of this. We want to use this for our solution. So what we should do, we go to here and we start with, we go to Simulink here. And start from blank file. Now it will take a while. Something goes wrong. I think we are good the other way. No, this okay now. It's coming. Usually we start here with library. Okay, under the library, sure. Okay, we come to Simulink library browser. We need commonly used blocks. And here we want, okay, we want this part here, which is integrator. Here we go. Okay. We go and ask for the other integrator here. Two integrators. Okay, now we can write here for this. Right here. Integrator from A to B. Right here myself for my reference. And here from B. So we have, we continue the loop like that. Now here, what we have here, we have acceleration. So we should give an expression for acceleration. How to write that? We have many options. The easiest option is to go here and search, because you're going to use this one for your own need. So it's better to have it in this form. Maybe because we want to multiply f times 5. Okay, maybe recommend use block. Looking for math functions, math math operations. We have e to the power minus t. So here we go. We have e here. And we're going to open this exponent. Right, so here we should have minus t going inside. What is minus t? T means time here. Time can be called by using the source. Source means clock. Here we come to the clock. Clock means time. Now we go here and search for gain. Okay, so we need to have gain is, we multiply this by a number here. This number is this number. Change the number. We click here and we'll make it 5. So 5 times t. We have initially t will go from here to here. It's 5 times t. It will go inside. 5 times t. This is not the way. We should remove this here. It should be the other way. Now we need to have this gain again. Now we move this one here and bring this here. See, it's 50 now. So it is minus t here. We should have minus 1. So let's make it minus t. Will appear here. So I have here e to the power minus t. Then I have to multiply this by control. I just say control V, like I have here. Multiply this by 5. So here you have 5e minus t. This is the input. Let's move this, we copy here. And we have like that. Okay, so we have here, the input is here. Okay. The input here need to integrate and then find the V in terms of here, we end up with S. That's it. Now, to see what happened here, we need to go to, I think we have here scope. We have one scope here and another scope there. Here we have velocity, and here we have like that. Okay, now, so what will happen? Okay, everything in terms of t. So this is straightforward work. Now the time here allocated is 10 seconds by default. We can make it 5. Okay, now what will happen if I ask it to solve? This is the initial conditions here for accelerations. I say the initial speed is 0. That here, the initial distance is also 0. So you can change that one the way you like. Then ask now to run. Now, ask it to see what happens here. This ones represent the velocity with respect to time. So starting from 0, the speed will go this way. The other one represents the distance, like that. We can rename the file here. Say this one is speed. This one here is S. Okay, you can change, make it here. Now again, you can see the speed. Here you can have them near to each other. That. So every time you come here and say a new term here, make it 20, for example, and then ask run. So here, the velocity becomes constant, but distance not it looks like a linear here. So this way you can find the integration. Okay, this is just a simple case. I think this will be helpful for you to start with Simulink. Okay, so if you have equations, you can always integrate the equation. Here you are integrating because you need to have the acceleration, expression for acceleration, and then using the expression for integration, you can use velocity, and using the velocity, you can find distance and so on. Okay. So you need to, now this is linear and straightforward work. If the acceleration is a function of the velocity or a function, yes, if the acceleration is a function of velocity, then it's becoming non-linear problem. Okay. So this is, and you can still program this. Okay, you can still program this, but I give this short introduction because I want you to start the process. You need Simulink. You need Simulink to finish your work. Okay, you can also use Excel. If you know how to use the numerical methods, you can use Excel for your own need, but maybe Excel needs experience. Need experience. It's not, you should have a good experience to use Excel. Very good experience. How to program and then follow the process, follow the speed and acceleration and everything using Excel. The easiest one is to write the equation and then convert them to a code like what you see now, just like that. Okay, so continue our work next time with another case of interest. Okay, all the best. Thank you.